In this video, I want to have a look at rational numbers. So I want to start off by just explaining what those are. So we've got this number family tree here, and right up the top it starts with real numbers. So real numbers are all the numbers that you have ever known. It then branches down into rational numbers and irrational numbers. So rational numbers are anything that can be written as a fraction. So then that's got two branches as well. We've got integers, which are whole numbers, and then we've got fractions. So rational numbers are anything that can be written as a fraction. We've got integers, and then everything else that can be written as a fraction. We've also got irrational numbers though, and it's got two branches as well. So we've got surds, so things like the square root of 2 or the cubed root of 3. And we've got transcendental numbers, which are things like pi or e. So irrational numbers can't be written as fractions. In this video though, we're going to focus on rational numbers, and I specifically want to look at converting between fractions, decimals, and percentages. Okay, so first of all, let's start off with a percentage. So let's start with 45%. And I want to convert that to a fraction and to a decimal. So write it over here again as well. So the first thing, if we want to convert that to a fraction, we've got to recognize that percent means out of 100. So 45% means 45 out of 100. So that's written out as a fraction, but we also want to simplify it down. So we look for the highest common factor of 45 and 100, which would be 5. So 45 divided by 5 is 9, and 100 divided by 5 is 20. So 45% as a fraction is 9 over 20. So we also want to do it into a decimal. Again, percent means out of 100, which means we want to divide this 45 by 100. So we'd move decimal place 2 places, and we'd end up with 0.45. Let's have a look then at starting with the decimal and converting it to a percentage and a fraction. So let's have 0.62. If we convert it to a fraction first, we need to get all of our digits in front of the decimal place. So we want to end up with a 62. But to do that, we would have had to move the decimal place 2 places, which is equivalent to multiplying by 100. So to compensate for that, we're going to divide by 100. So 0.62 is equivalent to 62 over 100. But we want to simplify that. If we divide the top and the bottom both by 2, we'll end up with 31 over 50. So that's as a fraction, but we want it as a percentage as well. Again, remembering that percentage means out of 100, so we'd have to multiply this by 100, which would give us 62%. Okay, the next one we're going to have a look at is starting off with a fraction. So say we had 1/4, and we wanted to convert that to a decimal and a percentage. When you're working with fractions, when you're starting with fractions, it's easiest to go to a decimal first and then go to a percentage from there. So we'll do that. There's two methods you can do this without a calculator. One of the best ways to do it is to make this denominator into either a 100 or 1,000 or 10,000 in the denominator. So it depends what this is and what multiples you can get. So that 4, we can turn that into 100 if we multiplied by 25. So we'd have to do the same thing to the top as well. So 1/4 is equivalent to 25 over 100. And then 25 divided by 100, we'd move the decimal place 2 places, and we'd end up with 0.25. So that's as a decimal. If we wanted it as a percentage as well, then we'd move it back the other way, and we'd end up with 25%. All right, let's look at one more example. So this one, we've got 4 over 11. So with this one, if we're trying to convert this to a decimal, we can't use the same method we did over here, because 11 isn't a factor of 100 or 1,000 or 10,000 or any of those numbers. So what we're going to do instead is we're going to actually divide. So like you used to do when you first learnt division, we're going to go 4 divided by 11. Now 11 doesn't go into 4 at all, so we'll put a 0 up here. And we're going to have to add in some zeros after the decimal place down here. So we've got our decimal point up the top as well. So 11 doesn't go into 4, which means we're going to carry the 4 over. So now we've got a 40 in this place here. So 11 goes into 40 3 times to give us 33, and then there'll be 7 left over. So now 11 into 70 will go 6 times to give us 66, and then there'll be 4 left over. So notice we're back to this 40 again. So we'd end up with a 3 up the top and a 7 left over, and then we've got a 70. We'd end up with a 6 and a 4 left over, and that pattern is going to keep going forever. So this is actually a recurring decimal. So we'd end up with 0.36 recurring. Okay, so that's going from a fraction to a recurring decimal. I want to have a last look now at going from recurring decimals back to fractions. The first example I want to look at is 0.7 recurring. So the method we're going to do this is we're going to write let x equal that number that we've got, so 0.7777 and so on. Then we want to get one of these recurring digits in front of the decimal place. So to do that, we'd have to multiply by 10. So that means that 10x would be equal to 7.7777 and so on. So then we're going to subtract. So we're going to say 10x minus x. So if we go this one minus this one, then all of these numbers, all the 7s after the decimal point, are all going to cancel each other out. And we're just going to be left with this 7 minus 0, which is just 7. So then 10x minus x would give us 9x equals 7. So x on its own would be 7 over 9. So since x was 0.7 recurring, that means that 0.7 recurring is equivalent to 7 over 9. Okay, one last example of that. So if we had 0.12 recurring, again, we'd say let x equal 0.121212 and so on. And we want to get one of these recurring periods in front of the decimal place. So because there's 2 digits now, instead of multiplying by 10, we'll have to multiply by 100. So that means 100x is equal to 12.121212. And then we're going to subtract again. So we'll go 100x minus x would give us, again, all those digits, all the 1s and 2s after the decimal place are all going to cancel each other out. So we'll just be left with that 12, which means that 99x would be equal to 12, and x is equal to 12 over 99. Okay, so that's a few examples of converting between fractions, decimals, and percentages.